daytime tower is typically your reference tower, but in this situation, the daytime tower is less power than the reference tower.
Okay.
So, because it's a 3/8 wavelength tower, which is a much more efficient tower than the little smaller tower out there.
You actually have yours set up where you can, if you were in daytime mode, can you read your current here, or do you have to go out to it? Okay. Yeah. Some people actually have it set up with a meter because the output of the transmitter feeds through this as well. I guess, or does it bypass the phaser here?
It goes through the bridge, but it doesn't go through this meter because you don't want to.
That's a lower. Yeah, if you had the people that use those have a higher current rating, so they can read the daytime power on that, and that's perfectly legal. If you calibrate this meter with, if you were supposed to run 11 amps or whatever down at the tower, and you get that set right, then you come back and see what this one reads and put that in your maintenance log or in your notes. So if you look up here and you're reading 15 amps or whatever it happens to be at 50 ohms, and then go down there, that should match whatever it says on the license for that. And that's legal to do that.
Yeah. And it's not uncommon that the common point meter would, like you say, also be the daytime base current remote meter. A lot of stations, especially if they're 5 kilowatts or 1 kilowatt or whatever, are close. But in Frank's situations with 50 kilowatts a day and 500 watts a night,
that's a lot of difference.
Yeah, it wouldn't work.
So in his case, when he's on daytime, he actually goes down to the tower and periodically. And you don't have to do that all the time. You do that as often as necessary to ensure that you're.
What normally I do is calibrate the transmitter meter
with the base current.
You can adjust those.
Yeah. Things. And as long, the way I tell people, as long as the transmitter power looks like it's running right and you've recently calibrated it down there, then you don't have to go down there every day or every time you come out here. If this begins to look squirrely up here, then you need to go down there and see. That's where that thing is, they say, as often as necessary to comply. Now, he's in nighttime operation, and we just read a while ago, his license says his common point current. You know, we talked about yesterday that you read the current going into the phaser, because this unit here actually splits the signal to go to the individual towers, and by these controls that you don't want to touch after you get it set, is that will adjust the amount of power going to the tower as well as the phase of the signal going to the tower. And there's some other things that go into making the pattern. It's the azimuth of the way the towers are mounted in the field, the distance they are between each other. I mean, there's a lot of things that goes in, but the only adjustment that you can make, because obviously you can't go out and move the tower or anything like that, so the only adjustments you can make are on these controls here, which adjust the amount of power and all. So we go and look and make sure that his common point meter is reading correct according to his license. And John read it with his good glasses, and it came out pretty close to 3.29. Now, since he's in directional, we can actually read the reference of the amount of power and phase of that power going to each tower. So if you want to show them how to do that, I'm not supposed to touch it, so you do it.
Well, we'll just measure right here. We'll go up here and get this up. This should be set to about 100. This will be the reference tower right here. And it'll bounce around a little bit. That's close enough. When you're in the reference tower mode, this will read 0. Then we'll go into the other tower.
Show them over here where you can make sure, in the little door, where you can make sure that it's reading correctly, when you do your.
Oh, that's a sense.
That's on the other tower.
Yeah, that's on the other tower. Yeah.
So that when you go to the non-reference.
But the reference is reading close to 100% or 100. We'll go into the other tower. The other tower should be reading 30.8, I believe. It's reading 30.7, 30.8. It's bouncing around there.
Yeah, 0.308.
There you are. Okay, the phase is supposed to be minus 150 degrees. How do you tell if it's minus? There's a button in here that you press, it drops down. That's telling me it's minus. If it was a positive phase, it would go up. So we're set there.
Now, just so you know, if this was one of the older style meters and it actually, as Larry's picture showed yesterday, actually had regular meter movement, then when you would push this button here, you'd see the meter move to the right for positive or to the left for negative. And again, a lot of these, you'll see multiple types of these units. You'll see those that have standard analog type meters, very much like this in them. You'll see that are digital like this, and then you'll see one that's totally automatic and does all the calculations for it. That was the latest version. So another thing, when you're looking at the phaser, you know, there are two types of phasers. There are the phasers that come with the Delta bridge. This is actually a piece of test gear here. You don't see quite as many of these as you do just a standard box that might have a meter in it, or this meter might be off to the side and it just be a box with knobs in it, and this unit wouldn't exist. So if you go to a site and you're looking at their phaser and you don't see something that looks like this, that doesn't mean that there's an issue or anything. It just means that they didn't buy the option to have the Delta bridge meter there to check the common point and the accuracy of the impedance on the station. So you'll see everything. I mean, you might walk into a station that's perfectly legal and you'll see all these open coils, and it might be behind a screen or of some type, or chain link fence, or in a room independent that's locked up and that nobody can access except the engineer. So there are a lot of styles of phasers. The preferred obviously is a cabinet because of the safety and the construction, and of course most people don't realize these cabinets also have effect on how the phase and the power is divided, just because of the fact that it's metal all the way around it. So that plays into it as well too.
The good thing about having this the bridge in here, this common point should be set at 50 ohms. And so when you use the formula we were talking about, power equals I square R, the R would be 50 ohms and the current would be this right there squared. Anytime you make an adjustment to any of the tower controls, it will throw this common point off. So he has a input phase here that will actually, you can actually, is that your common point?
There's your reactance. Yeah.
Oh, okay, I was looking at the wrong knob. That you can adjust these and get the impedance back to 50 ohms, because it will change as you rock those controls along. It will throw the common point out, because if you look at a schematic of the phaser, it's just a whole bunch of coils and capacitors that are all tied together, and obviously everything interacts with everything else. So before you can actually make an accurate reading on your common point current, you have to make sure that the common point is reading 50 ohms, because the output of the transmitter is 50 ohms. So that's how that actually works. Now, who knows what it is? Well, it should be 50 ohms leaving here going to the tower, but then when it gets to the tower, depending on what the resistance of the tower is, and I think here it says 40 ohms, the tower's not 50, it's 40 ohms, we think.
Yeah. Something you'll see on older transmitters. On the new transmitters, you have multiple power levels, and you can set a day power level and a night power level. On the older tube-type transmitters, they would play with the impedance so that the daytime might be 54 ohms and nighttime would be 50, and that way it would adjust the power levels back and forth so that the station, if they were 5 kilowatts day and night or 1 kilowatt day and night, when they just changed from day to night, the transmitter would automatically compensate because of the difference in the impedance, as opposed to having to adjust the power levels. Otherwise, nighttime for a 50 kilowatt, or a 5 kilowatt array, you may be putting 5,500 watts into it to compensate for losses in the system, whereas daytime it would just be straight 5. Like the 500 watts here, you're probably putting 550 watts
540.
540 for example, because there's a certain amount of loss in the system. But the transmitters, well, he's using separate transmitters. Here's the nighttime transmitter, and the large transmitter is the daytime. But if you're using the same transmitter, you'd either compensate by different power levels in the transmitter, or you would change the impedance. It's just one of those tricks of the engineering trade, but if you ever go to a site and wonder how they did that, that's how it's done.
Well, there's actually, in the rules, you're actually allowed, and I always forget the numbers, but if you're If you're 5,000 or less, you're allowed to increase your power. At 5,000 or less, you can increase your power by 5.3% or something like that. And if you're above 5,000, it's a different amount. I forget what it is. But the reason they do that, and this happens in television as well, they know there's losses inside this phasing cabinet, so that you're not penalized with the loss inside the phaser. They allow you to run additional power over and above. The transmitter may be reading 500 watts, like,
right.
or you're putting 500, but the transmitter may be running 540, but that's to take up the difference, and the commission allows you to do that. Television does the same thing. When you go through the mass filter and you read your with your Agilent power meter, you actually read that on the output of the phaser, of the mass filter, not the input, because of some loss in the mass filter.
Yeah, same thing for FM too. Yeah, same thing for FM. With the next stop, we'll see an FM combined system, and you actually compensate for the losses in the combiner system as part of the TPO of your transmitter. So if there was a dB of loss, you compensate for that by adding additional power to achieve your whatever you're, say if you're 100 kilowatts or 50 kilowatts on the FM side, you would cover for that loss in the combiner or any filters that they would have.
There's not a lot of loss in them, but they allow you to compensate for that, which I think is pretty nice.
Yeah, definitely.
So one question that comes up, switching between day and night, is that done automatically, and how is that?
Done through the remote control system.
So you've got that set up that actually does it.
Yeah.
It'll shut the 50 off.
Yeah, it does it automatically by a computer at the studio that talks to the Burke unit, and it's locked to the time is locked in, and it automatically at the right time switches them.
Now, here's a question that comes up quite often. Do you have any way that you know that it's that? Do you get any kind of indication that it has switched?
Here's the station log right here. This has got our EAS stuff on it here.
Okay.
It's also, we add information like I've got where the lightning strike hit.
Right.
Situation. I attach the printout from the index on here for EAS, and then it does a log every day. It prints a log. Tower lights off, south tower lights off, day antenna on.
Okay.
And it tells you the time right there. And the same thing here, it goes day antenna off, night tower on, the tower lights on, both towers.
The convention is really stickler about making sure that you switch your back and your power. If you're having to switch at night, which most AMs do, they get on the stations rather strictly if you operate with daytime power at night. I mean, that's not that's not a good thing.
Unless it's Friday night and you're carrying high school.
Yeah.
Emergency, isn't it? Yeah.
Well, I did, years ago, I did hear where a station actually called the FCC, and they were a daytime only station, and they asked for permission to stay on at night, and the commission wanted to know why. They said, well, Auburn and Alabama game is a night game, and we need to carry it. And they said, that's not a good excuse. He said, in Alabama, it is. We got to carry that game. So that's what you look at when you do the inspection, is find out from the engineer, how do you switch from daytime pattern or daytime power to nighttime pattern or power, and how do you know that it switched? You want to make sure, because sometimes things can happen to the remote control and it doesn't switch. And the next thing you know, you're getting calls from people that are picking you up in New York that shouldn't be picking you up in New York. So you got to make sure that you're.
Alarm 5 minutes on the nighttime switch.
Oh yeah.
If it doesn't switch, then the alarm system.
Oh, it does. Okay, so you get an alarm if it doesn't switch. Okay.
One thing we mentioned yesterday was the NRSC measurement that all stations are required to do at least once between 12 and 14 months. And here's a copy of his NRSC report. You're supposed to keep these for at least 2 years, and this is for a requirement for every AM station. This is a document that you're certainly going to look for when you go. It's not part of the public file, but it is part of the engineering documents that you're required to have at whether it's at the transmitter site or the studio.
Well, actually, I brought it from the studio
Yeah,
so y'all
so-
can see it. I keep.
Yeah, open that up and show the mass filter. It'll actually show the mass filter. The equipment that he uses actually makes sure that you're not splattering outside of your licensed bandwidth. So, and there's a picture.
Yeah, there it is right there.
If you exceed that, then you're not being a good neighbor to the people above and below you on the band.
This right here, we're outside the filter. That's because that's another radio station on 610 right there, which is noted right there.
Oh yeah.
So if you see that show up, make sure there's not another radio station,
Yeah.
because that's perfectly legal that way. And you have to do one for both the daytime and the nighttime.
Right.
That's why we have two for each. And there's the 2017.
Do you do them yourself?
No, this is done by a company that we bring in, the TNT.
Yeah, TNT. There are several. This particular company he's talking about, it's Larry Taft, I think is the guy's name, and he and his wife have a big Winnebago, and they drive around the country, and he's got all the equipment set up in the back of his Winnebago, and he'll just drive up and he'll call you on the phone and say, "I'm in town. I'm going to check your NRSC, and can you switch it to nighttime for me?" So you switch it to nighttime, and then he's on his merry way.
And sometimes he has no regard to the day or time. He called me Easter Sunday about 12:30 while we were eating lunch one time and said, "Can you switch it?" And I said, "No." He says, "Oh, I'm sorry." You know.
He's an independent.
He's an independent guy.
There are a number of independents all around. There are a couple of guys in South Georgia that do work. They're scattered around the country, and they do that. There's no reason why you can't do your own measurements if you have the equipment, but it takes a spectrum analyzer and a field intensity meter. Some people I've seen use the old Delta splatter monitor.
Yeah, I was going to ask you, do you have a splatter
Yeah.
monitor? Yeah, they
But-
actually make a splatter monitor.
Yeah.
I've got a spectrum analyzer.
Yeah, that's
and we
even
can do
better.
our own, but it's so much easier to let him do it than to go out in the field and sit at the cemetery over there is where I used to do them.
Yeah, you can't do it here at the transmitter building. You have to go about a kilometer away or something to get a good signal. But he's got his plotter printer in the back of his Winnebago, and he'll make the measurements and crank up and drive to the next station. So that's all they do. He and his wife do that. But that's a requirement to do that. The obvious reason is you don't want something happen in the transmitter all that will make you splatter out on either side. First of all, it sounds bad because it's splattering, but you've got a station pretty close to you on 610, and you could potentially interfere with them, and that would be obviously a monetary fine.
Okay, if you want to, we can switch it today. We can keep our fingers crossed.
Okay.
Let me.
You got a broomstick to do the switch, or?
No, I think it'll switch today. I may have to run out to the tower and push the contactor, but most of the time it makes it. Let me run around here a second. I'm going to turn the power onto this. It's going to give you an alarm because our night contactor is bad.
Yeah.
So it'll be a high-pitched noise.
Yeah. Normally you wouldn't have that, but he took a lightning strike the other day and knocked out his contactor that switches, so he's having to do it semi-man.
It's going to give me a high-pitched noise. Okay, we'll shut this one off. Now we're on day power. No, this is an MCDL transmitter.
Right.
Yeah.
That's why the power is going crazy.
If there's no modulation, it would be
Yeah.
single fit.
You can see that it's got modulation on it right now. Let me get about 7 here.
Frank, you got a monitor speaker, you turn up a little bit, can you see? Can you hear us?
Here, the monitor died. My antique radio died.
Yeah.
I was just
What are the people
listening hearing
I
right
can
now.
turn it off.
No, they just have better coverage.
But now it turns off. It's almost 550 kilowatts. It should be.
We're trying to explain to them what that is and how they came up with that.
What this does is supposedly saves on your power because a 50 kilowatt transmitter eats up a lot of power, and there's a lot of time that it can be operated at a lower power and achieve the same coverage. You can't tell that it's working but it's reduced our power bill about 20 to 25% by using that. The way it works is backwards than you think it would work. When no one's talking, it's putting out a full 50 kilowatts. When they start talking and modulating it, the harder they modulate it, the lower the power is, which doesn't make sense to a lot of people, but there's one reason for that. It's because when you quit talking, you've got dead carrier. If your carrier drops, the noise floor will come up, so it'll sound noisy. The international shortwave uses this, but they do it the other way around. When there's no one talking, it drops, because it doesn't really matter on them. But this one is the other way around. This is used in the U.S.
When did you put this in?
Put that in 2 years ago, 2 or 3 years ago. It's on the license. We have to have you have to tell the commission, notify them informally with a letter that you are working with MCDL, and they usually just say, okay.
What the inspector will have to, when you go out to look at the common point, he'll have to turn that off so that you can see the accurate antenna current.
This transmitter, we can open it up. It's a full solid state transmitter. This is one you can open up while it's on, and it's got a little module. This has got one module out, which is telling me that, but it doesn't matter. I've got to replace that module. And you can see the little red light in there. But if you turn the lights out on this transmitter, you can see the little green LEDs. There's LEDs in there, and they'll go, it looks like a giant meter jumping up and down. Because it just turns on the amplifiers when they're needed.
How many modules are there?
Oh God,
I thought they're numbered, aren't they?
yeah. 96.
96.
But each module has 2 in it. So it's double that.
Yes.
The amount that it's using determines on the modulation. How much modulation you need, how much power you're putting out.
It's supposed to be 34 ohms, or 34 amps. My other 50 kilowatt station, it's 49 amps.
This one HAS runs about 49 amps.
Yeah, they got a shorter tower. Yeah. That's a lot of current.
Yeah.
If you think this is bad, the 250 to 300 amps, I just put in a new FM transmitter that's putting out 26 kilowatts, a Harris Fax Transmitter. Its amperage is 870 amps at 43 volts.
It's all relative.
If something lets go, it's going to let go in there.
Well, it's all, you either got high voltage, low current, or high current and low voltage.
But the way it's designed, the way that transmitter is designed, it has 8 power supplies per power module, and you have 3 power modules, so you've got 32 power supplies, each of them operating on one phase and supplying a little bit of current. So you don't have 800 amps going through one conductor. It's just the sum of all of them. Turn this back on.
Okay. So make sure you ask the engineer when you come in, are they running this? If they're running the MCDL on their transmitter. Not all transmitters will do this.
No. The Gates transmitter, well, the Nautels, most modern transmitters will. The old tube transmitters won't. And also, if you're doing monitor points, make sure that that's all that transmitter is used on the reading monitor points. In our situation, we're using this other transmitter, which is a 1,000 watt transmitter, running at 500. There's no need for the MCDL. So it's always on.
Trying to think, I think the trade-off was maybe that 10 kW and above the MDCL was economical at that point.
That's why
Yeah,
it gets-
because 10 kW and below, your power savings weren't enough to justify the MDCL modification.
The other thing we look at when we come to a site, whether it's AM or FM, is how you monitor the tower lights. So how do you do that?
The tower lights are set up. Let me pull my log again.
That's right.
The remote control handles that. If you look on the log right here, you'll see where the south tower lights are off at 5:43 a.m. or 5:43, and the tower lights are on at 20, what was that, 19? 20 something,
2001.
2001. Okay, if they don't come on, then it says an alarm. It'll send us an alarm on that. And it'll show up on the log. I don't have an instance where it's not working. But it's running through the Burke remote control and through the autopilot software that we use with this.
So you get an indication daily if the transmitter didn't switch or if the tower lights don't come on. That's the way to do it, isn't it?
And it'll drive you crazy because your tower lights always fail at 2:30 in the morning.
That's one of those things. You have an automatic system then. That's what we talked about yesterday, that you can either check your tower lights visually or through some remote control, or in his case, he's got an automatic system that if it fails at 2 o'clock in the morning, it's going to wake you up and say, hey, the tower lights went off. So, which is actually the better way to do it, if you don't mind being woke up at 2 o'clock in the morning. Your EAS system's out here.
This is the FEMA. This site is a unique site, the only one in the state of Alabama, and each, I don't know, let's see, I don't know, I guess every state has one, so yeah. There are a few that aren't. But this is the FEMA system, EAS system. I can't use this. I can't do anything with this. We're a PEP station, which is a primary entry point station for the state of Alabama. The FEMA handles this. They've put in a satellite with downlinks here. This is a satellite downlink and the Comrex decoders. This is how they can control this. But this is still under test. So what they result to, a Telos phone interface. They dial in on a phone line, audio goes through this and triggers this. Now, the problem is, if the phone line goes out, nothing happens. They will call me and say, can you check the phone line? And I have to go check the phone line to see, and normally it's blown out one of our surge suppressors over here, because we put surge suppressors on it. This is where the nationwide test will come through, hopefully. This unit here. It is, like I said, we don't have any control of this. You can't get into this unit. I mean, you can't do the 1, 2, 3, 4. They've got their own codes. It's a specially designed unit just for FEMA. In fact, our old buddy Watt Harrison was out 2 weeks ago doing his inspection on it to make sure everything's all right. That's why we've got the big diesel tank out there. That's a 10,000 gallon diesel tank. It's not because we don't want to go off the air for any length of time. It's because FEMA put it out there. That's FEMA. They put the generator out there as well. Also, if you notice the two modules out there, those are FEMA modules that are soon to be put in here. Those are EMP Protected Modules. And one of them has a generator in it that is EMP protected. The other one has a 5 kilowatt Nautel transmitter in there and all the necessary equipment to put audio on the air and to do broadcasts from out here in the event of an electromagnetic pulse. My question to FEMA was, where are the radios? What's going to happen to the radios when that happens? Was it activated during 9/11?
No, it was not. There's never been a national EAS activation. There have been national tests, and PEP does do testing on a regular basis, and they haven't furnished you with a horse yet.
No.
Oh, okay.
No horse.
Yeah.
Or credentials to get past the line.
Right.
Which was the police line or whatever.
This is a system that's been around for a long time. PEP was the original way that the president had a way to send an alert. Now that IPAWS and the CAP alerting system, that is the primary method of getting messages from the White House. But that being said, that's fed on the internet, and in case of an alert or something happening, the internet may fail. So they still have the PEP system, which is a backup. At one time, these were actually fed by a HF radio system, which I think was fed out of Baltimore or somewhere, and you had a big antenna outside, like a ham radio antenna to pick that up, and they had some secret frequencies that nobody knew about that they could transmit from Baltimore or wherever it was to actually do that. Huh?
At 7, was it in Cincinnati with the old radio that had the triangle on it? Was that the same?
Oh yeah, that may have been part of it. Yeah, the old type, because it started long ago. That's old Conrad. Yeah.
You still pump that up once a year?
John, anything else we need to that you normally look at? We saw his logs. We saw his power. We saw the remote control.
I see a Marty transmitter down at the bottom. Are you doing TSL still?
Yep.
There you go.
Yeah. Save that. Yeah. There you go. That phone line.
We're putting in new Burke arcs, and we're putting the little telephone boxes with, because you can't get internet out at this place. They thought they were going to put it in, but they can't. It burns it up.
Oh, wait a minute. There's a site you can't get internet. There you go.
There you go. We'll have to talk to Josh, I guess.
That's great.
So that's what you do when you come to a transmitter. The first thing we do, check the power, because that's the most important thing. Make sure they're operating at the correct power. If they're directional, you go through looking at the directional, make sure. Typically, and we're not going to do it on this mock inspection, but typically you will get with the engineer and go out to the monitor points, look on his license to see what you're supposed to be reading at those particular monitor points, and go out and actually make the measurements. That verifies that the pattern. As I said yesterday, this meter up here is only showing what's happening out at the tower, not what's happening out in the field. So to verify that your pattern is what the commission says it's supposed to be, so that you're not interfering with somebody, you have to go out. Do you still go out and make field measurements?
This book is mine. The station logs in here, and I've got the work to do the monitor points. I do them once a month. Let's see if we can find one. And here we go. There it is. 6. I usually do them the first of the month, and here are the monitor point readings right there.
There used to be a requirement where you had to do that. I think it was like
Once a week.
Once a week? No, it was
no, once a month.
Once a month.
Like 31 days or something. You had to go out in the field and actually make the measurement. That rule has been relaxed if you have an approved sample system, which you have an approved sample system here. People have asked me in the class what an approved sample system is. It has to do with the type of cable that feeds out to the tower to monitor the current and the phase. It's and correct me if I'm wrong, John, but it's some sort of phase stabilized line that it doesn't vary.
Yeah, they're equal electrical lengths. So you have phase stabilized line. The line is cut to electrical length versus the actual physical length, because there may be some differences. And all the lines are equal length, and their extra line that you have at the site is actually buried in the ground. So it might be 100 feet to one tower and 700 feet to another tower. So the extra 600 feet are coiled up and buried in the field out there, and that's where it stays because both lines have to be of equal length.
So once you do that and it's approved that it's an approved sample, then you can actually use this. And I don't know that the rule actually states that you do have to go out periodically.
It's like the modulation.
Yeah,
It's often as necessary.
It's often as necessary.
Yeah, to make sure. So most engineers do, and it's a really good idea to make a practice to at least once a quarter.
I'm just old school. I've stuck to the once a month thing.
No, you just like to get out of the office.
Yeah.
Yeah, it also gets you out of the office to do that as well, but I usually suggest people to do that at least once a quarter, go out in the field, get you out of the office and get to see some scenery, and plus you remember, that makes you see that they haven't built a Walmart right where your monitor point is either.
One thing we might want to point out is that your monitor points can get off, but all the readings at the transmitter look correct. Cell towers. This is what you should be getting. You should be getting notification from the cell companies that they're putting towers in. And they have to, by FCC rules, they have to measure your monitor points before they put it in and then after they put it in. And if there's any effect, they have to do detuning. And this is done by, this is Lawrence Beer, which is a reputable company right here. This is the tower they did that's, if you look right across the street, there's one right there. In fact, when they built that tower, they begged me to reduce the power while they were working on it because it was burning them. That tells you how bad it was over there. So we cut the power down while they did that.
Well, what happens if anything gets built like a cell tower, it acts like a re-radiator. So that will affect your pattern and throw the pattern off. So where you know was correct beforehand, if they put up a cell tower or something like that, it could re-radiate, and that will mess up the what you're reading at the monitor point. Now you can, if somebody builds a Walmart or a building out there on your monitor point, you can apply to a move to a new monitor point, but you have to prove that what the reading is and all that. So
We have a monitor point now. We're in the process for this station of moving because it's in a very undesirable neighborhood. So we found out that the radial that's on there goes right directly to the police station, Fairfield Police Station, in the parking lot. That's where our new monitor point's going.
the only other thing that you look at a transmitter site, obviously, is to look at the tower and see how the painting looks on it. He's got his information about the tower lights, but you need to make a visual observation. Unfortunately, you can't use a chip chart on a tower that's running 50 kilowatts because it would burn up your chip chart plus yourself. So you just sort of have to look at it. There was a day that the commission said that the way that you would check the paint on a tower was when you were driving up. If you could recognize the difference in the color bands, that's what a pilot would see. But that's sort of been revised over the time where even though you can recognize the difference in the bands, it still doesn't match the right color. So that's why they require inspectors to have a chip chart to make sure that it's the right color and does not change to some pinky looking color or whatever. Anything else, John?
I don't have anything else. Any questions?
ASR numbers on the tower.
Did you see the gate?
Yeah.
Gate posted?
Yep.
Of the locked gate?
Huh?
The locked gate.
Yep.
On the lock gate. Right.
Yep.
So the point of first public access and an ASR indication line. You have one at the tower base as well too?
Yeah, on the
Yeah.
And you have
on the doors,
Yeah.
there. They need to be changed. They're wearing out. I just go to Kmart. I go to Lowe's or Home Depot and buy the stick-on numbers, and I put it on a little panel out there on the front gate. It's easier to do that than have it printed signs done, because printed signs will get stolen and messed up. They cost money. So we're just trying to save the company money. That's all. Yeah. Oh yeah. They call it Habu in Cumulus.
Any other questions? Guess we go on to the next site.